Read each statement below carefully and state with reasons and examples if it is true or false. The situation is a particle in one-dimensional motion. Suppose a particle in one-dimensional motion. First case is asking whether it is true or false. With zero speed at an instant may have non-zero acceleration at that instant. If a particle in one-dimensional motion with zero speed at an instant and may have non-zero acceleration at that instant. If a particle is in one-dimensional motion, the first condition is zero speed. Zero speed, and at that time, at that same time, it's supposed to have non-zero acceleration. Zero speed and non-zero acceleration. This statement will be true. It's a true. Trump. I'm getting Trump. It's a true. So the situation is like that when a body begins to fall freely under gravity. So freely falling motion also one-dimensional motion. That's remember carefully. When a body begins to fall freely under gravity, so in that case, if you remember, in that case the speed is zero, but it's having non-zero acceleration. So speed is zero and acceleration is non-zero. If it is falling gravity, acceleration value minus 9.8 meter per second square. So this situation happens in one dimension, so that is true. So that is case A. Let's see case B. Case B says if in one-dimensional motion with zero speed may have non-zero velocity. Zero speed may have non-zero velocity. So this is false. Why it is false? Because speed is the magnitude of velocity. If you remember velocity and speed formulas, they both are same, but what happens, velocity having direction but speed not having direction. Speed is the magnitude of velocity. If zero is speed, may not have non-zero velocity. So in that case, if speed equal to zero, obviously velocity is also zero, because speed is the magnitude of velocity. So there is no particular situation in one-dimensional motion where speed is zero and the velocity is non-zero. So in one-dimensional motion this statement is false. Let's see the third statement. With constant speed must have zero acceleration. Constant speed with zero acceleration. This happens in one dimension. Speed is constant. Suppose if I draw corresponding three graphs. Suppose if I want to draw parallel three graphs. One is position versus time, one is velocity versus time, one is acceleration versus time. So let's take position versus time. They're given that third constant speed. Speed is constant, must have zero acceleration. Yeah, but if an object is moving with uniform velocity, so this is a uniform velocity displacement. So to this we can represent the speed is also, suppose to that graph the velocity. So the velocity also, if I represent in that constant, so velocity also gets constant. So if the velocity is also gets constant in the same direction, so there is no change in the velocity. Velocity is constant. If the velocity is constant, what about the rate of change of velocity? If you know the acceleration formula, acceleration equal to dv by dt. If velocity is constant, it means the derivative of a constant, d by dt of constant, what's the value? It goes to 0. So in that case acceleration value is 0. Suppose if it is acceleration versus time, so acceleration equal to 0. So the third case happens. So the third case, the case C is happens with a constant speed must have zero acceleration. So when a particle moves with a constant speed in the same direction, neither the magnitude nor the direction of velocity changes, so as acceleration is 0. If I write this, when a particle or an object, when a particle moves with constant speed, in the same direction, so neither magnitude of direction changes or magnitude of speed changes or velocity changes, so acceleration is 0. So I can say the statement C is true. So we can represent the statement C is true. So this is a true statement. Let's see the fourth statement. The fourth statement says with positive value of acceleration must be speeding up. It is telling must be speeding up. So if it must, we can say that is false. Positive acceleration must be speeding up. No, it cannot be true, because if an initial velocity of an object is negative, take object having its initial velocity negative, then even in case of positive acceleration, the body speeds decreases. So a body speeds up when the acceleration acts in the direction of motion. So finally we can conclude that a positive acceleration must be speeding up. So the word must is not acceptable at here. So because if you say, suppose a object is having a velocity negative, suppose if I draw velocity versus time graph at here, oops. So this is the velocity versus time graph, but the object is having negative velocity. Suppose this object is having negative velocity. So when time increases, this object velocity is decreasing. So here negative velocity negative 1 meter per second. So when time is increases, the object velocity is decreasing. Let me take this as 4 meter per second at here. So in this case, even if you see the acceleration, what the acceleration, you can find that acceleration equal to the rate of change of velocity. So even though the velocity value here it is decreasing, but the acceleration here it is positive. So I can write that as a concluded statement. If the initial velocity of a body is negative, if the initial velocity of a body is negative, then even in case of positive acceleration, so this is the point what we required at here. So we were asking about positive acceleration only. The body speed downs or decreases. So even it is having the body speed is decreasing. Instead of -1 to it decreases -4 meter per second. So acceleration means that a body speeds up when acceleration is in the direction of motion. Positive acceleration, we can say that positive acceleration is only when body speeds up when the acceleration is in the direction of motion. When acceleration is in the direction of motion. So we can say the statement D is false. So this is how we need to analyze the given situation. Let's try one more problem. A player throws a ball upwards with an initial speed of 29.4 meter per second. What is the direction of acceleration during the upward motion of the ball? Let us do one by one. Suppose this is ground. So this a player. So he is throwing a ball. So it is in hand. So the ball is move upward. So this is at top. So he throws the ball at 29.4 meter per second is initial velocity. What is the direction of acceleration during the upward motion of the ball? Direction of acceleration. The direction of acceleration in the upward motion. What could you guess? Yeah, it's a negative. In upward. The direction of acceleration upward is negative. Or acceleration acts always downwards. Acceleration in downward direction. Because due to gravity. So the acceleration in this particular case will be acts downward direction. So this is the reason the ball velocity at the top is decreases. So when an object is moving upward direction, its acceleration direction is downward direction. That is due to because of gravity, acceleration due to gravity. Now see the B part. What are the velocity and acceleration of the ball at the highest point of its motion? Suppose if you take this is the highest point. So at this point, what are the velocities and acceleration? Yeah, velocity at this highest point equal to 0. Yeah, that's the reason the velocity became at here 0 from 29.42. So that's the reason the ball do not went up to there. If it could have little velocity, it may go up to there. But after reaching at here, the velocity becomes 0. Velocity equal to 0. What about acceleration? Acceleration do not be 0 because acceleration due to gravity do not vanish. It always presents there. So the acceleration at the highest point for the B, acceleration at highest point equal to 9.8 meter per second square. Earth acceleration gravity do not vanish at here. That's the reason acceleration should be present. But velocity it became 0. Let's see the C part. Chose the x equal to 0 and t equal to 0 seconds to be the location and time of the ball at its highest point, vertically downward direction to the positive direction of x-axis, and gives the signs of position, velocity and acceleration of the ball during the upward and downward motion. So they are giving a situation. The situation is at x equal to 0, t equal to 0 to be the location and time of ball as its highest point, vertically downward direction to be positive direction of x-axis. So to see situation, I need to draw something. Suppose if I draw, this is a positive x-axis. So x is positive. At this situation, x equal to 0 and time equal to 0. So I need to draw time axis also. So let me this take as time axis. This is time axis. So this is the situation at x equal to 0 and time t equal to 0. It's the highest point. Oh, this is the highest point. So I should mention it here. So highest point, let me be present at highest point. Now what we need to represent during upward motion and during downward motion, what is position, velocity and acceleration sign. So during upward motion, suppose from here I am throwing the ball. So the ball is going all the way like this. So I throw the ball with 29.4 meter per second and during upward motion. So give the sign of position first. So position sign. So position means since it is a positive x-axis and at the highest point is 0, so position is always positive. Yeah, if I go upward direction also, position means it's changing only positive. Suppose here you can take this is 10 meters, the above it takes as 8 meters and above at you take 2 meters. So like that, position at here positive only. Position is positive. What about acceleration? Acceleration formula, change in position or final position minus initial position. Acceleration equal to position, velocity. I need to talk about the second one. It's supposed to velocity. Velocity is nothing but change in position, x2 minus x1 upon t. Suppose if I take x2 as 10 and x1, since ball is moving up, x1 supposed to I take as initial minus final. So x2 is the final position, it means it is 8 meter, and x1 as at 10 meters. So this is my final position when ball is moving up. So this is position final, xf, and this is position initial, x suffix I. So the velocity is nothing but x2 minus x. So here I am getting the negative, whatever the time is. So the velocity when moving upward direction, so it is negative. So when velocity is negative, so I can write that velocity sign is negative. So what about acceleration? If velocity is negative, acceleration is positive. Yeah, the rate of change of velocities. So that is what happens in the free fall. In the free fall, the velocity of the object is decreasing, the acceleration value goes to increases. So here the acceleration sign is positive. Here is the acceleration of the object, not the acceleration due to gravity. Be careful. I am not talking about anything about the acceleration due to gravity. In the free fall, the acceleration due to gravity is always negative. But here we were trying to find the acceleration of the object what we are throwing. Since the velocity is negative, the acceleration becomes positive because it is change in velocity. So that is what happens in the upward motion. So comes to downward motion. During downward motion, now during downward motion, think about all these three. What happens about position? Position is its only positive x-axis, the position is obviously positive, and velocity is nothing but change in position. So now this time the object is falling, change in position, so obviously here it becomes positive because the final value becomes more than the initial value. So it becomes exactly opposite to the first situation. And what about acceleration? Acceleration, the object is falling. When the object is falling, the acceleration of the object also positive because falling body is having more acceleration. So think about these three situations, how the position and velocity and acceleration of an object which is thrown in upward directions and downward directions will changes. So try to analyze the velocities here carefully. And come to the D part. To what height does the ball raise and after how long does the ball return to the player's hand? So it means here we need to find the total path length. At what height the ball raises. So to calculate that, so whatever the value is given, so for upward motion, we can use this values. U initial velocity is given minus 29.4 meter per second, and acceleration due to gravity is upward motion, it is positive. So here it is plus 9.8 meter per second square, and the final velocity at the highest point, its value goes to 0. Now at what height? Height means I need to find the s, displacement. You use third equation of motion, v square minus u square equal to 2as. So final velocity 0 square minus initial velocity minus 29 point whole square, which equal to, so 2 times 9.8 times s. 2 times 9.8 times s. So therefore s equal to minus of 29.4 whole square upon 2 times 9.8. So if you can do this calculation, we can get that s equal to displacement s equal to minus 44.1 meter, roughly, approximately minus 44 meter. Okay, here what is the negative sign says? So the negative sign says the object covered distance. Initially we have taken 0, but finally it covered the 44 meters. So negative sign shows that the distance is covered in upward direction. Now for the second part, at what time it reaches, total time. So total time, first I need to calculate time to go up plus time to go down. They both are same. Time to go down, then only it reaches to the object height, sorry, in the player's hand. Suppose this is player, he thrown the ball. How much time it went up to there? The time of ascent. This is called time of ascent. Time of ascent. And here equal to time of descent. Ascent means upward direction and descent means downward direction. For total time, what we have to take? We have to add up. So for the time, use the first equation of motion, v equal to u plus at. Since acceleration we know and initial velocity already you know that. So 0 equal to initial velocity minus 29.8 plus acceleration 9.8 times t. So therefore t equal to 29.8 upon 9.8. If you do this division, this you can get 3 seconds. So time of ascent equal to 3 seconds and time of descent also 3 seconds. Why? Because since acceleration is same, so therefore the total time taken is equal to 3 plus 3 is equal to 6 seconds.